Welcome back, students. So in the previous session, we had discussed about we had discussed about function, like what is the definition of a function, and we had discussed a special type of a function, that is one function. I hope you're clear with the definition. So to begin with, we'll just revise the definition. So what do you mean by one function? That a function is said to be in one if the images of distinct elements of x under f are distinct. That is, you can find a mapping in such a way that suppose you have elements a, b, c, x, y, z, then one element, distinct element of x, is mapped to distinct element of y. That is, images are unique. You can find only one mapping from a to that particular element. You cannot find any other mapping from the image set. So that is a to x, b to y, c to y. So if someone asks us to find that how to show that a function is one giving, provided they have given us the function in the form f of x is equal to 2x. So what we have to do, we have to assume that suppose their images x1 and x2 are two elements from the domain set, and we have to assume that f of x1 is equal to f of x2. What is f of x1? F of x is 2x. What is f of x1? That is 2x1 is equal to 2x2. So that is nothing but x1 is equal to x2. So if we can prove that, if we have two elements x1 and x2 from the set x, such that their images are equal, then we can show that those are nothing but they are not the two elements, they are the same elements. In this way, we can show that a given function is one or not. Okay, now coming to one more type of function, that is onto function. Okay, so before going into onto function, I need certain terms to be cleared, certain definitions to be very clear for you. So you have two sets. Okay, so this is x, this is y. Okay, and if they give f of x is equal to some y. Okay, so now whatever x we take, okay, whatever x we take, that should come from the set x. Okay, whatever x we take, that should come from the set x. So this set is called as domain set. This set is called as domain set. So whatever y I get when I put that value for x, when I take some value from set x, some elements from set x, and if I find what is the value whatever I get, that should be in set y. Okay, that should be in set y. Generally set y is called as codomain set. Okay, generally set y is called as codomain set. Only those elements which are the images of some element in x, those elements which are the images of the some element of the set are called range of the function. Range of the function. I hope you are clear. Y is generally the set y. Okay, y is called as codomain set. It contains all the elements. Range is only those range contains only those elements in the set y which is the image of some element in the set x. Range is contains only those element in set y which is the image of some element in set x. Okay, I hope you're clear with these definitions: domain, codomain, and range of the function. Okay, so to begin with, what do you mean by onto function? Onto function is, here onto function means you have two sets, set x and set y. Okay, and there will be a mapping defined by f. Okay, and suppose set y has a, b, c, and here if you have x, y, z, w. Okay, so something like this you have to say that a function is onto. What you have to make sure is every element in set y, remember, every element in set y, that is a, b, c, should be a image of some element in set x. Okay, every element in set y should be a image of some element or in set x. ಯಾವುದಾದ್ರೂ ಒಂದು ಎಲಿಮೆಂಟ್ ಇದು ಇಮೇಜ್ ಆಗಿರಲೇಬೇಕು. That is the definition of onto function. That is, if I have a mapping of this kind, you can see that a is okay. So now So what as I was saying, you can see that all the elements of set Y, that is A, B, C, is mapped to is the image of some element in set X. Only then we say that the function is onto. In general, what did I say? This is a codomain set, correct? What do you mean by range? It is the images of some element. Range, what is range here? Range is a set which contains which are the images of some element in X. So what is the image here? It is nothing but A, B, C. Because A is also image of some element, B is also image of some element, C is also image of some element. So you can see that what is Y? Y is also set A, B, C. Already I have told that Y is called as codomain set. So you can see that range set is equal to codomain set. So one more definition for onto function is range should be equal to codomain set. Range should be equal to codomain set. Okay, so what is the first definition? Says that every element in set Y, should be a image of some element in set X. Every element of set Y should be image of some element in set X. I hope you're clear. Also, this onto function is called as surjective function. The another name for onto function is surjective function. Okay, I'll give some more example to make the definition very clear. So here you have three examples, 1, 2 and 3. What you can observe in the first example? So far we have studied about one function, many one function and onto function. So which kind of function is this? First, for 1, 1, it should be one element going to 1. Whether this is a 1, 1 element? No, because you can see that A and B has same image. So this is not 1, 1. So this function is a many one. So in order to be onto, every element in set Y should have an image. Whether D has an image? Yes, D is an image of some element. E is an image of some element. F is not an image of, because you can see there is no mapping there is no mapping to X. That is, there is no element in capital X which is mapped to F. Correct? So this is not onto function. This is neither 1, 1 nor onto, but this is a many one function. Now if you go for the second example, you can see that whether it is a 1, 1 function, A goes to one function, A goes to one element, B goes to one element, C goes to one element, D goes to one element. There is, you can see 1, 1 mapping. So this is a 1, 1 function. Whether this is a onto function, remember, if the function is 1, 1, then it cannot be many one. Okay. So this function is 1, 1 function. Whether this is onto, what is the definition? Every element in set Y should be an image of some element in set X. So what are the elements in set Y? 1, 2, 3, 4. So you can see 1 is an image of A, 2 is an image of B, 3 is an image of C, 4 is an image of D. So this is an 1, 1 and onto function. Coming to the third example, you can see whether this is a 1, 1 function. No, because A and C is mapped to same element. This is a many one function. So this is not 1, 1. Whether this is onto, what is the definition for onto? Each and every element of set Y should be an image of some element in set X. What are the elements in set Y? D and E. Whether D is an image? Yes, D is image of two elements in set X. And whether E is an image of some element in set X? Yes. So this is a onto function, but this is not 1, 1. Okay. So if a function is both 1, 1 and onto, that is, if the function is injective and surjective, then we call it as bijective function. Bijective function. If a function is 1 1 and on 2, then it is called as bijective function. That is, if it is injective and surjective, then it is called as bijective function. I hope you are clear with the definitions. Thank you.